Work and energy. Work is the use of force to move an object over a distance. The equation for work on how to calculate it is work equals force times distance, or W equals F times D. The standard unit for the work is a joule, or also a Newton times meter. Energy is the ability to do work or to cause a change. Energy. Kinetic energy is the energy of motion. The faster an object moves, the more kinetic energy it has. The equation for kinetic energy is Ke equals 1/2 times mv squared, with m standing for mass and v standing for velocity. The standard unit, again, for energy is joules. Potential energy is the stored energy, the energy that an object could have. Mechanical energy is the combination of both kinetic and potential energy an object has. The equation for mechanical energy is Me equals Pe plus Ke, meaning mechanical energy equals potential energy plus kinetic energy. A pendulum is an object that is suspended from a fixed support so that it swings freely back and forth under the influence of gravity. These are a couple of diagrams to show you what a pendulum looks like. If you've ever seen a grandfather clock, then you've seen a pendulum as it swings back and forth calculating the seconds. Forms of energy. Thermal energy is the energy an object has due to the motion of its molecules. The faster the molecules in an object move, the more thermal energy it has. Examples include the biggest example of heat energy in our solar system is the sun itself. The sun radiates heat to warm us up on the planet. When the burner of a stovetop is very hot, it is a source of heat energy. Anything placed onto the stovetop and warmed, whether it's a pot of tea or a skillet for frying, becomes sources of heat energy. Automobile fuels such as gasoline are sources of heat energy, as is the hot engine of a race car or a school bus. So for thermal energy, you need to pick one of the examples to write on the lines on your notes for thermal energy. Some more examples of thermal energy include a toaster is turned on and turns a piece of bread into a piece of toast. This is due to the radiant heat energy of the toast, which draws moisture from the bread and makes it crispy. A hot cup of steaming cocoa contains heat energy. Any fire, from the smallest match to the biggest forest fire ever, contains heat energy, with even the smallest of fires potentially resulting in the massive amount of heat energy seen in a huge blaze. When ice is placed into a glass of water, the heat energy of the water eventually melts the ice, meaning the water itself is a source of heat energy. A radiator or heating system in a home provides radiant heat energy to warm a house during those long, cold winter months. Conventional ovens are sources of convection heat energy, causing the food placed into it to become hot and cook. Your body contains heat energy that can warm a cold glass of lemonade, melt the ice on the other side of the window, and make someone else warm when you hug them. Geothermal energy is a type of heat energy generated and stored beneath the surface of the earth. This type of energy is used to heat homes and buildings. A huge amount of heat energy is stored in a bolt of lightning, which can strike and start a fire or cause an electrical outage. Heat energy is contained inside a hot piece of pizza. If it doesn't cool down, the heat energy has the potential to hurt the roof of a person's mouth. When your computer is turned on, the components inside of it generate heat energy, which needs to be cooled with a small fan installed within the machine. A bathtub filled with hot water contains enough heat energy to warm a cold body back to a comfortable level on a frigid day. There is heat energy inside a cat that can be transferred to a person when the warm animal jumps up onto his or her lap. So there's plenty of examples on types of thermal energy. Chemical energy is the energy stored in chemical bonds that hold chemical compounds together. If a molecule's bonds are broken or rearranged, energy is released or absorbed. Chemical energy is used to light up firework displays. It is also stored in food and in matches. Examples of chemical energy include batteries, biomass, petroleum, natural gas, and coal are examples of stored chemical energy. Usually, once the chemical energy is released from a substance, that substance is transformed into an entirely new substance, such as food. Nuclear energy is the potential energy stored in the nucleus of an atom. In a nuclear reaction, a tiny portion of an atom's mass is turned into energy. Nuclear energy can be used to run power plants that provide electricity. Examples include electricity and the atomic bomb. The origin of nuclear energy is from the splitting up of uranium atoms while nuclear fission. The main process for the production of nuclear energy is fission, fusion, and nuclear decay. Nuclear power plant is a kind of thermal power plant in which heat is generated from the nuclear reaction and fission reaction. This heat energy is used to produce steam, which rotates the turbine, and hence electricity is produced. Electromagnetic energy is the energy associated with electrical and magnetic interactions. Energy that is transferred by electrical charges or current is often called electrical energy. Another type of electromagnetic energy is radiant energy, the energy carried by light, infrared rays, waves, and X-rays. Examples, again, there are many forms of electromagnetic energy, including gamma rays, X-rays, ultraviolet radiation, visible light, infrared radiation, microwaves, and radio waves. Power is the rate at which you do work. The equation for power is P equals W over D, which means P equals power, W equals work, T equals time. So you would take the work divided by the time to get the power. The standard unit for power is watt, or joules per second. Technology is the use of knowledge to create products or tools that make life easier. A machine is any device that helps people do work. Machines make work easier by changing the size of the force needed to do the work and the distance over which the force is applied, and the direction in which the force is exerted. Mechanical advantage is the number of times a machine multiplies the input force. The output divided by the input would be how you calculated the mechanical advantage. Mechanical advantage is the output force divided by the input force, and the efficiency is the ratio of the machine's output work to the input work. So an ideal machine would be 100% efficient. Actual machines, however, lose some input work due to friction. So the efficiency equation is what you see below. Work output divided by work input multiplied by 100%, because efficiency is based on percentages. Simple machines. The 6 simple machines on which all other mechanical machines are based include inclined plane, lever, wheel and axle, pulley, wedge, and screw. A lever is a solid bar that rotates or turns around a fixed point or a fulcrum. Examples of levers in everyday life include scissors, tongs, a seesaw, and a pliers. Wheel and axle is a simple machine made of a wheel attached to a shaft or an axle. Examples include cars and bicycles, screwdrivers, steering wheels, doorknobs, and electric fans. A pulley is a wheel with a grooved rim and a rope or cable that rides in the groove. As you pull on the rope, the wheel turns. Examples include a flagpole, curtain rods, a sailboat, a tow truck, a crane. An inclined plane is a simple machine that is a sloping surface. It's stationary, it won't move. Examples include a ramp. A wedge is a simple machine that has a thick end and a thin end, often moved to do work, used to cut, split, or pierce objects or to hold objects together. Examples include a doorstep, a chisel, ice scraper, axe, or a knife. A screw is an inclined plane wrapped around a cylinder or a cone to form a spiral. It's used to raise and lower weights as well as to fasten objects. Examples include drills, jar lids, screw clamps, nuts and bolts. Ideal mechanical advantage is for an inclined plane on how to calculate it. For an inclined plane, you would take the length of the incline divided by the height to figure out the mechanical advantage. For the wheel and axle, you would take the radius of the input divided by the radius of the output. For a lever, you would take the distance from the input force to the fulcrum and the distance divided by the distance from the output force to the fulcrum. Compound machines are a machine that is made up of two or more simple machines. Examples include scissors, fishing rod, car, gas, pencil sharpeners, typewriters, lawnmowers. Most of the things that we work with on a daily basis are compound machines, more advanced, because you've got at least two, if not more, simple machines put together to make something. Compound machines typically must overcome more friction than simple machines because they tend to have many moving parts. And these are the resources that I used.